Assalamualaikum warahmatullahi wabarakatuh. I'm Said Mahaqil Muhammad and from University UIN Raniry Fakultas Science and Technology. I'm here and will the Revien Jurnal, the title CNN Hyperparameter Optimization as use random grid coarse-to-fine search to face classification. The written this journal is Ade Nohor Pipa with Nuriza Amelia Rasti. Department of Informatics, University Amikom, Purwokerto, Indonesia. Abstract. Convolutional neural network (CNN) is a regularly used populated machine learning technique to classify images. However, choose an optimum and efficient architecture is an inevitable challenge. The research goals was to implement CNN on face classification from low-quality CCTV footage. Hyperparameter optimus strategy used with the random grid coarse-to-fine search optimization approach. This approach combines random search gates search and the coarse-to-fine techniques. That was usually and efficiently applied, yet working well. Exhaustive random search process was done with evaluating selected activation function and chose another hyperparameter randomly. The SLU activation function used in the next step was the one with the best average performance. This process aimed to locate optimal value gradually in hyperparameter with head dimensional spins. Evaluation of the model result from the optimal hyperparameter was 97.56%. Introduction. Application that uses big data have been where they use the most industry and research. Some details are the use of CCTV video footage, social media, sensor data, agricultural data, medical data, event space research data, automation of surveillance video on CCTV. It is an important and interesting subject to learn. Image classification is part. It includes many applications such as object detection, location, and segmentation. CNN's algorithm, the which use a recognition pattern, show as traffic detection, human detection on next vision camera, facial recognition from attention system, and facial recognition on CCTV use the detect and track validation. CNN's development is accelerating with the new structure, new optimization technique, and the availability of data. The line scale. There is no specific reliable approach to identifying network structure that led to significantly the performance. CSN performance relies on hyperparameter whose value cannot be altered from the data. Determine the optimal combination of CNN hyperparameter. It is a challenge because of its computational complex. That's because words dealing with shared space and high-dimensional dataset. Research method 2.1 Preparation image data that used in the study with 3,000 facial images of 21 people manual labels. These images come from the process of detection. Detects the face through to the process resign. Image manual 100x100 is product. Process formation sheet. The process of the process image is carried out by improved image quality, image enhancement, and normalization of that. The process of image refinement is carried out because the quality of the result image is low. The CNN model, which created by study dataset partitioned with plotting validation techniques. This method is used because it's a good performance in studying a small number of datasets. It also had stable performance for fitting head accuracy. In training set and generalization that a good form validation set and testing set. The model option will provide facial label partition on the same tested. CNN implementation. CNN is a deep learning architecture influenced by the human ability to quickly recognize objects and environment. Deep learning techniques have featured vector engineering capability that can manipulate vector automatically. C3 is no need to build vector extraction model. Is often complete. Based on learning techniques, deep learning can be classified into 4 parts, namely depth supervised learning, DUL, depth supervised learning, DCL, depth semi-supervised learning, DCCL, and depth reinforcement learning, DRL. In the case CNN belong to the solely assist sector. The 4 definitions are the basic sector of CNN, the classification activation function to fault connection layer, the image input to configuration layer, to polling layer, to configuration layer, to polling layer, and the following connection layer. This the process CNN implementation. 2.3 Network structure hyperparameter. The hyperparameter optimized in this study is hyperparameter associated with network structure, including activation, function, number, and set of kernel, and number of nodes on a full connection layer. The kernel on the CNN network is a special presentation in the models. This most will used kernel is the outset kernel with a event set kernel in release use and approach. There is not direct relationship between kernel set and accuracy. It's the future a small The implementation of a Linux kernel can lead to loss of information from two factors. The information upfront only on the training, not on the base that cause the model to overfitting. 2.4 CNN optimization. CNN's algorithms has averaged our hyperparameter to 1 or 4. The more completed the structure of CNN, the more difficult it is to determine the combination of hyperparameter used. 2.4.1 Grid search. The grid search approach is easy to implementation and reset in low-dimensional space. Moreover, the abbreviation is trivial. Grid search is the hyperparameter search method by testing the model to all expected value. 2.4.2 Random search. Random search is easy to use optimization strategy, but it often works better the other optimization approach. In the random search approach, the sample point is not taken regularly, but the random is the interval between instances. The sample attacked randomly in the optimization results are also different. 2.4.3 Coarse-to-fine techniques. Step 1. The search is array R1. The X-min and X-max symbol optimization value is this area with X1, F1. Step 2. The search in smaller area R2, X1 min beta X1, X1 plus beta X1. Assume the real optimal value is the interval symbolity of optimal value in the R with X2 by F2. Step 3. Repeat step 2 with beta X2 is smaller than beta X1. Stop when the estimation value X E5FE is area RE plus does not change. By carrying out this technique, there will be a chance to get faster optimal value with favored search. Result and distribution. A CNN model that has not been optimized when used to evaluate image and segment result table show the result of the initial evaluation gave the best result by 92.92 89% accuracy value, while the loss function value with cross effort was 0.2990. The next process is the exclusive random search process by evaluating all activation function and selecting other hyperparameter at random. Figures 4 show a graph the loss function of the story. Complex from the smallest to the large. The average sigma loss function produce the hex value of 0.9443 and and had a head defective. Celu has the smallest standard definition of 0.0628 and show a more stable result will set the smallest irregular function value of 0.1327. This graphic the result definition of the ReLU, ELU, Sigmund, ReLU, and Tan, Soxen, and Sockplus. Furthermore, with this hyperparameter is done right to find grid optimization the number of kernel and the number of nodes on a fully connection layer and the short get to optimize kernel side. The result of the evaluation of node number 4. The table to optimal value with grid coarse-to-fine reset method is hyperparameter number of kernel layer 2 and 1 and 2 optimal value layer 2 59 accuracy 0.9733. The layer 2 values 30 accuracy 0.9689. Number of value in the connection layer code layer nodes layer 1 optimal value 52 accuracy 0.9667. Layer 2 value optimal value 91 accuracy 0.9756. Kernel side layer 2 optimal value 7 accuracy 0.9756. Layer 2 optimal value 5 accuracy 0.9756. The table 5 hyperparameter ultimate value hyperparameter activation function strip optimal value SELU number of kernel layer 1 59 layer 2 63 kernel side layer 1 7 layer 2 5 number of value connection layer nodes layer 1 73 layer 2 91. Finally, the best model of hyperparameter optimization result is show is number 1 visual qualification use CNN with this hyperparameter result in accuracy up to 96% The accuracy of this result model is better than previous study using a counter propagation neural network CPPN of 60%. Conclusion: this result applied hyperparameter optimization of CNN neural network study structured by combining random result, gesture, and coarse-to-fine technique. The product model is implemented of face detection image that have low quality. The application of CNN algorithm before image became a product accuracy of 56%. The nosing will flat inform image quality. Therefore, it improved accuracy value by 92 90.89%. Hyperparameter automation of identification function use expect random search improve accuracy up to 97 to 11%. Next, by using the coarse-to-fine method, the other hyperparameter, the accuracy was steadily accuracy up the 97 56%. Okay, thank you the watching from Revien Jurnal. The title CNN Hyperparameter Optimization use random grid coarse-to-fine research for face clarification.